All right, in this video, I'm going to show you how to perform a two-mean hypothesis test when the population standard deviation is unknown. So the problem says, a manufacturer buys a particular electrical component used in its products from two suppliers, supplier A and supplier B. Raquel is a manager for the manufacturer and is looking to determine whether there is a difference in the reliability of the components from each supplier. She collected a random sample of 30 components from each supplier and determined the time to failure for each component in hours. Raquel records the failure time for each component. We're going to assume that the population variances of time to failure for each supplier's components are equal, and that the distribution of time to failure for each supplier's component is normally distributed. We're going to let the time to failure for supplier A's component to be our first sample, and then the time to failure for supplier B's components to be our second sample. We're going to conduct a two-mean hypothesis test at a 0.01 level of significance to test if there is evidence of a difference in the mean failure time between each supplier component. So again, and we talk about two population, our new hypothesis is always that the means are the same. So our options here are option number 2, 3, or 4. Now, for the alternative, the only thing we know, or the only thing we need to know is, or we want to know, if there is evidence of a difference in the mean failure. We don't have direction. We don't have anything that is telling us here whether the time failure for suppliers A's components is smaller than the time to failure for suppliers B. So since we have no direction, we go with just difference, mu1 different than mu2. So this in here is going to be our response for that one. Then we have our data and we are going to perform the test using RGuroo. So again, download the CSV. We go here, we import our dataset. We choose the file from our computer. Change the name if you want. Upload. Then you get your summary, you get your dataset. We're going to close in here. We're going to open the analytics tab. The analysis, the mean inference, and means inference for two population. We're going to select our data set here, supplier. All right, again, variable number 1, it's supplier A, and that is in here. Supplier A is the first sample. Supplier B is the second sample. So we go here, we do supplier B. So we have everything. We don't know the standard deviation of the population, so we don't have information to fill these two boxes. We leave it like that. We go to the population 1-2 tab. We go to the test of hypothesis test tab. We change this because we want to do we want to use a significance level of 0.01. Our alternative hypothesis is different than, and again, this is a 0 and this is coming from, this is our alternative hypothesis. If we subtract mu2 from both sides, we have mu1 minus p mu2 on the left, and then we have mu2 minus mu2, which is a 0 on the right. Because we don't know the standard deviation of the population, our method is going to be a t-statistic test. It's a t-test. Everything's in here. It says here, assume that the population variances of time to failure for each suppliers are equal. So because we have that information, we are going to change this here to equal variances. And then we click on the I and we have our response. So we go here, we need our test statistic and the p-value. The observed t-statistic is, we want 2 decimal places for the test statistic. So that's going to be 10.26, 10.26, and then it says for the p-value to use 3 decimal places. So again, p-value is 1.21 e, and then 10. This is a 10 to the power of minus 14. So this is telling you to move your decimal point 14 times to the left because it's negative. So when you do that, you actually end up with a 0. It's a very, very small number. So here we have our test statistic, our p-value, after we perform test on RGuroo. Then we continue here. We need to make up our decision. With a p-value such small, we reject the null hypothesis, which means that we have enough evidence. We have sufficient evidence at a 0.01 level of significance to conclude that there is a difference in mean time to failure between the components from supplier A and the component from supplier B. And from here, if you have any questions about how to perform a hypothesis test for the mean of comparing two populations when the standard deviation is unknown, please let me know.